Our next goal is to be able to answer the question, how can you describe the graph of f of x is equal to a times the quantity x minus h squared plus k. Now this is actually called the vertex form. Okay, so vertex form of a quadratic function. In the past 3 lessons, we learned about um, the standard form. So the standard form that we've been using is ax squared plus bx plus c. So this is called the standard form. Standard form of quadratic function. So this one, the one that we're going to look at in this lesson, is called the vertex form. Vertex form. So why is it called the vertex? So before we answer that question, why it's called the vertex form, let's have a little bit of history first. In the past 3 lessons, we look at the different transformations of the parent function x squared, right? We said that the value of a tells us whether it's concave up or down, or whether there's a vertical stretch or shrink, while the value of c tells us whether the graph moves or was translated c units up or c units down. Okay, so this form now is called the vertex form because, well, it doesn't contain all those constants in the standard form like a, b, and c, right? However, it's called the vertex form because it automatically gives you where the vertex is at. If you remember, in the previous lesson, we had to use a formula, negative b over 2a, to find the axis of symmetry, and then we plugged it in to find where the vertex is at. So this vertex form of quadratic function automatically gives you the coordinates of the vertex. So how? If you have x minus h, you get the opposite of this part, and the x coordinate will become h. So if you have x, if you have x minus 2, the value of h is positive 2. Or if you want to look at it as, some students remember it easier if we just say, alright, if you have an x minus 2, you get the opposite of negative 2 and it will become positive 2, right? But technically, it's just the same number that comes after the minus sign. There are just instances when the expression is given by x plus 3. My God, you can hear my kid in the background. So in this case, this is the same as x minus negative 3. So that's why if you're given a plus sign, okay, the value of h here is actually negative 3. So it's easier to think of it as, x minus, what do you call this? X minus negative 3 or x plus 3. So just get the opposite of the expression here in the quadratic term, and that will be the value of the h. Now, for the k value doesn't change its sign, so pretty much whatever the sign here is, that will be the same sign of k in the vertex. Well, aside from giving you the vertex value, all the transformations that we learn about the constant a, they still hold true. Everything that we learn about the constant c, if you remember last time, I wrote down a x squared plus c, right? So that c is the same as the k value here. Alright, I just want to make sure that you understand the difference. Well, there is no difference, but you understand how they're related. So pretty much the constant that was added to the standard form of quadratic function is now just being replaced by the value of k. It's just because in some textbooks, especially in Algebra 2 textbooks, the vertex is always given by h and k, so we just want to be consistent with that. Okay, so let's clean this up a little bit. Next, let's look at the h value here. If k, or our original c, was the vertical translation, the h now gives you horizontal translation. But take note of what I wrote over here. You are reversing the direction. So remember, when we get the vertex, we change the sign to its opposite. The transformation kind of behaves in the same way. So if I have an x minus 2 here, let's just write down an example, x minus 2 to the second power. So 2 is a horizontal translation, not to the left, but it's going to be to the right. So it's going to be in the opposite direction. So x minus 2 means horizontal translation 2 units to the right. Now, conversely, if I have something like x plus 3 to the second power, then the positive 3 here means horizontal translation 3 units to the left. Okay, so that's how we use the value of h and its sign in finding the vertex and in transforming the graph. So later on, we're going to look at some examples on how the h affects the graph in our table of values.